In this video, I will be teaching you how to simplify radicals with variables. Please go ahead and press pause and copy this into your notebooks and then resume the video to learn how to simplify these. So for this first one up here, we have the square root of x squared. Keep in mind that when you do not see the index, which is the root we are finding, it is understood to be 2. Taking a square root of something means to find how many pairs of the factors of the radicand do we have so that we can reduce it. So what this really means is to find the square root of x squared, I'm finding the square root of, if you think about what x squared means expanded, x times x. And if my index is a 2, then that means I'm looking for how many groups of 2 of a repeated factor do I have? I have one group of 2 x's. So one group of 2 x's means that this will simplify into x to the first power. 1 meaning one group, 2 x's meaning my index was 2 and I needed to form groups of 2. So x to the first, of course, is simply x. If we contrast that with the square root of x to the fourth, again with an understood index of 2, it means I'm finding the square root of the product of 4 x's. So again, my index is 2, so I want to pair my factors up. I form 2 groups, therefore my answer would be x, meaning the factor, and the exponent of my answer would be how many groups I formed. So again, exponent in answer is how many groups, or how many, in this case, pairs are formed. Exponent in your answer represents how many pairs of that factor we have. So how many pairs of x are formed. So if I do likewise with the square root of x, which is the product of 3 x's, this one's going to be a little bit different in that because my index is 2, I pair this up, but that means I only have one pair of x's, and whatever remains unpaired stays in the radical. So I would just write that as x root x. So in other words, what I want you to see is that for every pair, one of those factors comes out. So this, I have one pair of x's, so x is going to come out. Here I have an x come out, and then here I have another x come out. Once they come out, they're no longer on the inside, so therefore I lose my radical. Here, likewise, 1 comes out, but 1 remains. So I have the one that came out and the one that remains. So if we keep that same thing in mind for x to the fifth, 1, 2, 3, 4, 5 x's, how many get paired up? 2 are paired up, so that's x squared, 2 to represent what? The exponent in our answer represents how many pairs. Now, this one does not get paired up, so it remains under the radical. Again, if I pair them up, 1 comes out. Pair these x's up, 1 comes out. X times x is x squared, but 1 remains. So, what might be another way of thinking about how to find these answers without having to expand out all of our x's? Because if you think about it, if I asked for x to the 40th power, I don't think you would want to write out 40 x's. So the shortcut is that we can divide the exponent by the index. So I'll recommend that you pause this in a moment, but There are two methods. You can either expand to find pairs of the same factor, or you can divide the exponent by the index. So I'm going to come and do this here in the margin. So in other words, if I have the square root of x squared, doing this with pencil, and my index is 2, if I divide this exponent by the index of 2, then I'm going to get x to the first power. If it divides evenly, which it always will if it's an even number divided by 2 is going to always divide into a whole number, then the number of times it divides into it is the exponent of my answer. So it's just x. So similarly, again, the square root of x to the fourth, if I divide by this index of 2, I'm going to get x squared. Over here, when they are odd, and I divide by my index of 2, we're going to think, well, 2 goes into 3 one time with 1 left over. Again, if I have the square root of x to the fifth and I divide by this index of 2, then that means I have 2 going into 5 2 times. So the whole number of times it goes in is going to be the exponent on the outside, and then I'm going to have 1 left over. So in case you're a little not like unclear on that, 5 halves is 2 divided by into 5 like this. 2 goes into 2 goes into 5 2 times. 2 times 2 is 4, and then I subtract and get 1, so I have a remainder of 1. So that's what I'm doing. I'm just not showing the math for it, right? So 2 goes into 5 2 times with 1 left over. So the whole number of times it goes in is my exponent on the outside. If I have a remainder, that's how many I have on the inside. So kind of two different methods to show you what's going on. We can either expand it and form pairs, or we can divide by the index of 2. So I'm going to ask you at this time to pause your video to record, to add all of this to your notes. So when we check for notes, all of this should be written in. So again, we can either expand to find pairs of the same factor or divide the exponent by the index. But these are some very important things. One factor comes out of the radical for every pair formed. I said that multiple times up here, right? If I form a pair, 1 comes out. Here, I formed a pair, 1x comes out. I formed a pair, another x comes out. If it doesn't get paired up, it stays under the radical. So they're right there. If a factor cannot be paired up, it stays under the radical. So that's just word form of what I've been repeating, okay? So we're going to go ahead and work through 5 examples, and then you're going to do your Delta Math assignment independently. And there are, let's see, there are just 11 problems for you to practice today. All right. So on to this one. If we have a perfect square, so you can see here all of these examples, guys, I'm combining both numbers and exponents. So we already learned how to take the square root of numbers yesterday and the day before, the 2 prior lessons. This is called a perfect square, meaning I have 2 of the same factor. We should know our perfect squares. The square root of 81 is 9. And if you don't remember how to do that, we go to our calculator, and if we press second, then the x squared button right here, and then type in 81 and press enter, we would get a 9. Okay, square root of 81 is 9. But we should know these. So the square root of 81 is 9. And then because my index is 2, if I divide, I get x to the 5th. Now, why does that work? And I'm just going to come up here just to illustrate an example with both a number and a variable. If I draw a big radical, because I'm going to put several factors in there, 81 is 9 times 9, and then I have 10 x's. You can see why we would not want to do this all the time necessarily, right? If I have a pair, 1 comes out. 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 I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, This pair, 1x comes out. I have this pair, 1x comes out. So now there's nothing left because everything paired up, but what came out? A 9 came out, and 5 x's, which we represent as x to the 5th power. All right. This time, when I take the square root of 49, we should know that that is 7. When I either expand it or divide by 2, how many times does 2 go into 7? 2 goes into 7 3 times. 3 times 2 is 6. Subtract, and I have a remainder of 1. So that means I formed 3 pairs and had 1 x left over, and that remaining x has to go under the radical. So my answer would be 7x cubed times the square root of x. If you need to expand this out, 7 times 7 and 1, 2, 3, 4, 5, 6, 7. In order to do that, then you can go ahead. Okay, I'm not going to keep doing that though. Next, for example 3, we have the square root of 72 and x. Well, 72, is that a perfect square? Let's see. Try to adjust this so you can see my calculator well. Let me see if that helps. So if I try to take the square root of 72, is it a perfect square? Sorry. Try to adjust this one more time. See if it works. So we can tell by looking at the decimal that this is an irrational number. It's not a perfect square. So therefore, we want to use the method we learned in the prior lesson, which is to go to y equals, type in our radicand, and divide by x squared. So again, I'm just going to write this over here to the side example 3. I'm go to y equals, and I'm typing in 72 divided by x squared. And then I'm going to look at my table for the last integer ordered pair. So you should remember this from the prior lesson. So second graph, it'll always be positive and always be after the 0. So I've got a ordered pair of 172, that's a whole number, but so is 2 and 18. So is 3 and 8. Is there any one after 3 and 8? Yes, 6 and 2. Remember I said that once you get, I'm sorry, you probably weren't seeing that. I didn't realize you couldn't see it. So again, we have 1 and 72, 2 and 18, 3 and 8. We're trying to find the last whole number ordered pair. Once we get into 0 point stuff, we're not ever going to get a whole number. So therefore, it'll be the last one up here. And that was 6 and 2. Y'all see that? That was the last whole number ordered pair. So if I have 6 and 2, our job is to remember that 6 goes on the outside and the y value here goes under the radical. So that would be 6 root 2, but of course we have a variable. So if that's the case, let me focus this again. In terms of our square root of 72, we're going to have 6 root 2. And because we only have one x, we cannot expand it into several x's. There's only one of them. It cannot get paired up, therefore it remains under the radical. So that would be 6 root 2x, or 6 square roots of 2x. Next, for example 4, I'm going to try to take the square root of 169. So hopefully we remembered our perfect square. Square root of 169 is a perfect square. It is 13 times 13. So the square root is 13. And remember, you can think of this as expanding it out or just dividing by your index of 2. The even exponents are always the easiest because that means 4 divided by 2 is 2. The odd ones, some students have trouble with that. So just recognize that 2 times 2 is 4. So that means I can pull out 2 pair. I can form 2 pair, but I'm going to end up with 1 left over. So if it's odd, we should always have 1 left over, right? Again, that's 2 into 5. So that's 2, remainder 1. So in other words, 2 outside with 1 remaining. Okay? Last one here, we have the square root of 192, x to the third, y to the seventh. So I didn't bring it up, but over here was the first one we did that had multiple variables. So we can definitely have multiple variables. We can have 3 variables or 4 variables and very large exponents even. So let's take a look at this very last example. We have the square root of 192, x cubed, y to the seventh. Now, I don't know the square root of 192, so I'm just going to check to see if it's a perfect square. And it is not. Therefore, we again want to do the method where we go to y equals and type in 192 divided by x squared, and we look for the last integer ordered pair, or whole number ordered pair. So 192, you should be doing this with me in your calculator, pausing the video as necessary. 192 divided by x squared. Hit second, then the graph button. And then starting at 0, what's my last integer order pair? I have 1 and 192, 2 and 48, 4 and 12, and 8 and 3. Oh, and that's the last one before I hit 0 point something, right? There's better. So again, the last integer order pair is 8, 3. So that means my 8 goes on the outside with my 3 on the inside. But now I also need to take care of these variables. So again, I can divide by 2, but just for the sake of anybody else that might need to see me do this one more time, 1, 2, 3, 4, 5, 6, 7, I'm going to pair these up. So I'm forming 1 pair of x's, that's going to come out, and 1, 2, 3 pairs of y's. So that leaves me with 8, 1 pair of x's, 3 pair of y's, and what's left in the radical? This 3 and 1 more y. Okay? So remember, every time we pair one up, it comes out. So we had 3 y's come out, that's y cubed. We have 1 x come out, and that's 1 x. And there we go. So now it's your turn. Go ahead and go to the Delta Math assignment. And right after example 5 here, all of your problems, all of them, should be in, there you go, should be in your notebook. So add 1 through 11, work, problem and answer with anything you're doing to simplify, any work included, and take pictures of it and submit it into Canvas. Hope to see you on Zoom. Let us know if you have any questions.